Hello, Accelerated Math 6-7 students. We are starting, believe it or not, Module 5, Lesson 1. And Module 5, Lesson 1 is called Area of Polygons. And it's going to be on whatever page number you are on in your comp book, Area of Polygons. So let's take a look at this. Trying something new again and see how it goes. These are our notes. So I decided to print them out instead of having them on the iPad because I think we'll have a little bit better of an option for viewing. So area of polygons, the goal. Today we will learn how to use the area knowledge to find areas of many shapes. Okay. The question that I want you to be thinking about is, what area do you use to find the area of other shapes? Earlier in the year we had guest visitors for NEU Teach, where they talked about a lot of this with you. So we have officially moved into our geometry standards, and we're going to be using area of one shape in particular, or maybe another shape in particular, to help us find the area of other shapes that can be broken down into them. So maybe that's jogging your memory to remind you. Things to remember. How do you find the area of shapes? Okay. Finding the area of shapes, you need to remember what area is, and that answers the next question of what is area. The way that you find areas of shapes is you figure out the dimensions of the covered area or the space that you want to identify, and then you try to determine how much space that is. So, for example, if I have a rectangle, then I know that I am looking for the amount of space that is inside it. So the shaded part, the part that I'm coloring right now, this is all considered the area of the rectangle. So in order to find the area of the rectangle, I have to know the dimensions of how wide it is. I also have to know the dimensions of how long it is, because once I figure that out, then I can say that if I take this width this many times, then I can then figure out what the shape space represents. Okay, so another way to say that is that you're taking the width, right, times the length, because when I take this width and I multiply it by the number of times the length is, that's showing you how much space is covered. Okay, so area, going back to this question, area is the amount of space available in a given shape. So you're going to write that right there. The amount of space available in the given shape. Okay. Is there anything specific that you must remember when working with area? I would say the most specific thing that you have to remember is that area means that we're taking one dimension and we're multiplying it by another dimension. So when you multiply two things, when you multiply two things, your answer represents the dimensions squared. Because squared means to multiply by two things. So we're taking the width times the length, and so whatever the units of measures are, they have to be answered in squared because you multiply two things together. Okay, so that would be the specific thing that it's asking you to remember when you're working with area. So area equals squared, area equals squared, area equals squared, because you're taking two things and multiplying them together to get area. So area always represents something squared. All right, so finding the area of a rectangle. On these, what I wanted to do is I wanted you to notice how to find the areas of these different shapes. So in order to find the area of a rectangle, like I've been working with you, you need to write this off to the side. Finding the area of a rectangle means that you are taking the length times the width. Okay, so that's how you find the area of a rectangle. Well, finding the area of a parallelogram is exactly the same because watch, if I was to take a pair of scissors and cut along this perpendicularly so that this now, I know it doesn't look like it according to the drawing, but this would become a 90-degree angle. If I cut this little section off and I move it over here to right here, then that cut off piece would sit right here. And when you do that, another 90-degree angle gets formed. This is a 90-degree angle, and this is a 90-degree angle. So what new shape do you see when you do that? And if everybody says a rectangle, then you are correct, because you can take a parallelogram angle. So how do we the width? So when you're finding parallelograms, you do the exact same thing. And so the area for a parallelogram is the length times the width. Okay, so there's that one. All right, so now let's look at a triangle. Notice it says right triangle. It has a 90-degree angle in it. So do you see any shapes up here that could help us figure out how we find the area of a triangle? What if I drew this? What shape is now formed that you see? If you're saying rectangle again, you are correct. So what did we learn about a right triangle? A right triangle is actually half of a rectangle. So if it's half of a rectangle, then all you have to do is take the length times the width, right? And then cut that in half. So take the whole thing and cut it in half, or multiply it by 1/2, which is the same thing as dividing by 2, right? The length and length times width divide by 2, or half the length times the width, okay? So that's how we find the area of a right triangle. And this should be a review from when the NAU Teach team was here. Okay, so let's keep going because I have a couple more for you. How do you find the area of a trapezoid? Okay, and I want you to look really carefully. Okay, so again, I'm seeing something. If this is a trapezoid, which it is, could we cut at a 90-degree angle right here? And could we put that one over here? Yep. Okay, so there's that idea. But trapezoids are a little bit different because they actually, what happens with a trapezoid is that you need to take another one. So you take two trapezoids. And when you take two trapezoids, it looks something like this. And now, what shape do you see like this? It's hooked all together. Two trapezoids hooked together make a parallelogram. So if we go back to our parallelogram, how do you find a parallelogram? Length times the width. Well, this one, you're going to do length times the width, but you also have to then cut it in half because there's two trapezoids and we only want one. So we look at just the original trapezoid, and we have the length of this one. So we're calling this length 1, right? And then we have the length of this one. So that's length 2. Well, if you look at our picture, length 2 gets added onto here, right? So now we have length 1 plus length 2. And down at the bottom, we have length 2 plus length 1. So that becomes our new length. And then our width is how tall it is. So it could also be the height. So if we're thinking about it as a parallelogram, then we have the length of 1 plus the length of 2 times, right, the height, which is also the width. So this could also be the width, right? So length times width. But then this is for the whole parallelogram, which we don't want. We just want half of it. So what do we have to do to all of this? Divide it by 2. Okay? So we have the length of the top plus the length of the bottom times the width, which happens to be the height. And then we don't want a parallelogram, we want a trapezoid, so we divide it by 2. Okay, another way you will see it is you're going to take base 1, that could be that one, plus base 2, which could be that one, divide it by 2, right? And then multiply it either of these will give you the exact same answer. Okay? All right, so that's what we know about a trapezoid. And composite figures are the last one that we're going to talk about. Composite figures are figures that have more than one shape added together. So do you see the rectangle? Do you see the octagon? So we have multiple shapes making this figure. So we know how to find the area of a rectangle. So the area of the rectangle, you're going to write area of a rectangle equals length times width. Okay? Now an octagon is kind of a crazy shape in itself because it has lots of shapes inside it. So we have, we could draw two lines right there, and then here's another area of a rectangle, so area of the rectangle, and that's length times width. And then what shape is this? Trapezoid, which you just learned up there. Or if you don't want to deal with the trapezoid, then you could figure out this is a triangle, and this is another rectangle. So there's lots of different ways to figure out the areas if you can see all of the shapes that are in there. And once you figure out the area of all these different shapes, so you have to find the area of the triangle, the area of the rectangle, the area of the triangle, add those together, then you have one over here that's just like it. So you actually take all of this times 2, and you add it to the area of the rectangle inside, and then you have to add it to the area of that rectangle that's sitting right there because it's a rectangle all by itself. So these are called composite figures. Composite figures, again, are figures that are created by more than one shape put together. And when I say put together, that means added together because we're taking the area of this rectangle and we're adding it to the area of this octagon. Okay? So kind of some neat stuff. So one last thing for you to fill out very quickly to review what we just talked about. Formulas for finding area. The area of a rectangle is length times width. The area of a parallelogram is length times width. Area of a triangle is length times width, or base times height, cut in half. Okay. Area of a trapezoid, again, is base 1 plus base 2 divided by 2 times the height, which is the exact same thing as this picture up here. And then area of composite figure, take the areas of all the shapes used to make the composite figure and add them together. So basically, we just summed up what we talked about with all of those. All right, and I do have a try this for you. You're going to do it by yourself, and then we'll check it in class in the morning. So here's the shape. It is a composite figure. You need to figure out what is the area of this entire composite figure. Don't forget to write down your dimensions so that you know what they are. All right, let's return to our goal really quickly. Our goal today was, we will learn how to use the area knowledge to find the area of many shapes. We did that a lot. Question, what area do you use to find the areas of other shapes? I would say we use the area of a rectangle the most. Okay? All right, and that's all I have for you today. Talk to you soon. Bye.